Hey guys, hopefully this video is super fast. Forgot I should probably talk about the insides of the similar figures, right? When I take a shape and I dilate it to make it smaller with a smaller scale factor, or the opposite, dilate it, make it bigger with a bigger scale factor, something that changes is its size, correct? It still looks the same, so the lengths of the sides will change. They'll still be, have the same scale factor. If this line got 1, 2, 3. If this line got 3 times longer, then however long this one is has to also be 3 times longer. If it's not, then it wouldn't look the same. It'd be like maybe this triangle here. These two triangles are not similar. This has a short line and long line where these are the same. So get that guy out of here. Now, when we talk about this though, the insides are the things that don't change. And by what I mean by that is the angles won't change. Every three-sided figure, every single one, has 180 degrees inside. All triangles have 180 degrees. This angle plus this angle plus this angle will always equal 180 degrees. And that's true for that one I told to get out of here. I'll bring him back. He also has 180 degrees inside him. Get out. Get out! Ya bum! So if I were to say this angle here, I can say with pretty certainty without even measuring it, is 90-degree angle. So 180 minus 90, I have 90 degrees left. These are the same exact angle because the sides are the same. So this is 90, so half of it would be, this one is 45, and this one is 45. Add them all back up, it'll equal 180 degrees. Same would be said for this one. If I took this big triangle out and put in the similar but smaller triangle, this is still 90 degrees. It doesn't change. This is still 45 degrees. Whoops. And this is still 45 degrees. The difference was, actually, let me try a different color. Maybe it'll help see it. The lengths, now, of course, this is not going to be perfect like me, but it'll look good enough. The lengths changed. This was, I said 3 units. This was 3 units, and I believe I said this was 3 units just for the sake of the argument. I know it's not quite that. So the other one was 3 of these is what I made. So the new one would be, to the best I can draw, 1 unit, 1 unit, 1 unit. But as you can see, if I drew a ray going through it with a center of dilation, this still is 90 degrees, this still is 90 degrees. This still is 45 degrees, and this still is 45 degrees, right? Now, if I flip this over real quick and went to that weird shape I told to go away, come back, come on, we like you now. No, we don't. I could look at this, and again, with pretty certainty, I could say that's 90 degrees. Now, I can tell that these are different. This is a much smaller one. It's a lot like me, if you zoom in. This angle right here, we like to call this the lens angle. You want to know why? Because it's a cute angle. Oh, man. Kazam! All right, so if that's 90 degrees, this one here, I'm going to make up numbers just because I don't have anything to measure in front of me. I have 180 degrees. I've already used 90 of it, so I'm left with 90. This one here, I'm, like I said, making it up. I could say this one is 60 degrees because it's bigger than this one, and I'm left with 30 degrees over here. It might not be that exact. This one maybe is 58, and this one is 32. I'm just kind of generalizing here that this weird triangle that no one liked, inside would still have 180 degrees, but if I made a similar triangle that had a dilation that was bigger, again, that's not right, but the idea there, this would still be 60 degrees, this would still be 90 degrees, this would still be 30 degrees. The difference is, look, the lines got longer.